So at this point, you might be wondering, can I always find the derivative? And there are a few cases where derivatives don't exist. And so we want to talk about when do those cases come up. And in general, there are two things you want to think about. One thing that you want to think about is if there's like a corner or a sharp point, that is a place where a derivative is not going to exist. So if we're looking at a graph and we can see that a function has a corner or a sharp point at a particular value, the derivative of that function is not going to exist. The other thing to consider is that if the tangent line would be vertical, it also would be a case where the derivative would not exist. So if the tangent line at that point were vertical, and so I'll give you some visual examples of these types of things. So the first one that we're going to look at, we're actually going to look at the absolute value function. Okay. And the absolute value function, the actual definition, of how it works, is it can be thought of as a piecewise defined function where the value of f of x is equal to x if x is greater than or equal to 0, and negative x if x is less than 0. And that's what the function looks like when written in that piecewise notation. And specifically, if we consider a graph of the absolute value function, what it looks like is it looks like a giant V with the pointy part here at 0, or at 0, 0, sorry, the origin. So it has one of these corners or sharp points right here. Okay, so by definition, we have a problem with the derivative at that particular point. You can actually prove using the definition of the derivative that when we're trying to find the derivative of this function, it's going to come out to be the limit as h approaches 0 of the absolute value of h over h. And this limit does not exist. Okay, so because that limit does not exist when x is 0, that's how we got this, by the way, is I if you wanted the full treatment of this, we would use the definition of the derivative. We would plug in 0 for x because this point that we're interested in is when x is equal to 0. That, the thing that I've circled here, the limit of the absolute, h approaches 0, absolute value of h over h, that's what we would get. And that limit doesn't exist. So at that sharp corner point, the limit doesn't exist, and therefore the derivative doesn't exist, because how we get the derivative is by taking that limit. Okay, so that's one type of scenario. This is just a specific example with the absolute value function, but if you're dealing with a function that has a corner or a sharp point like that, the derivative is not going to exist there. Where else do derivatives not exist? So the second thing that I said is if there was going to be a tangent line at a point, that was going to be vertical. Okay. So if you had, for example, let's look at like a squiggly, curvy, something like this function. So it starts off kind of high on the y, up towards the y-axis, curves off to the right, and then drops down very steeply, very sharp, and then bottoms out and goes off to the right. And if I wanted to look at the derivative, say, right here, if I wanted to look for the derivative at that particular point, this is not going to have a derivative. And that's because if I think about what the tangent line would be, you know, tangent lines, again, are these lines that only only touch our curve at like a very particular point, right? Very particular point. They're touching at one place, one single point, and then they're leaving. Well, if we think about a vertical line, like if our line right here is vertical, first of all, it's not going to touch the curve at just one point. It's going to touch the curve at a bunch of points. And secondly, when we're thinking about the fact that we're looking at the equation for the tangent line, vertical lines have undefined slopes. So the derivative cannot exist at any point where the tangent line is vertical for that reason. It is undefined. Okay, so we do not have derivatives if you're dealing with a graph that has a vertical portion of it. Okay. And those are really the only two things that you need to keep in mind. If you're ever in doubt, you know, if you're looking at this, like let's say you were looking at this and you were thinking, man, am I absolutely sure that the limit doesn't exist here? You can always put whatever expression you're interested in, like here we have absolute value of h over h. You can put that into the y equals on your calculator and look at the table like we did when we were doing the section on limits. Look at the table of values and see what happens there. And you will actually, if you do that with this particular equation, you'll end up with a table of values where you have, like, let's say here's our 0, and this will say, I think it says NA. And if you go to the left a little bit, so let's say negative 0.001, and then this is 0.001. So to the left of 0, you're going to have a negative 1. To the right of 0, you're going to have a positive 1. That's one of those cases where the limit at the point where h is 0 doesn't exist, and the values on either side are not converging to a single value. Okay, so we can also verify to ourselves that the limit doesn't exist by taking a look at the table of values.